I'm Andrea Marquez, a senior at Carver Military Academy, and my project is titled ShatterZone. This is my abstract and safety sheet. For my acknowledgments, I would like to acknowledge Ms. Murray for supporting me through the process of my glass shatter analysis and providing me with materials. I also would like to acknowledge some of my classmates that have each helped me in some way throughout my experiment, whether it was taking photos, helping me prepare for the experiment, helping me find the farthest glass shatter from the center point, or taking notes. The purpose of this experiment is to explore how the height of an incident affects the amount of glass shatters created and the radius of the glass shatter spread. For my hypothesis, I hypothesized that if I change the height at which I drop a white glass plate, then the amount and radius of the glass shatter spread will increase the higher I drop it. This will happen because the increasing height of falling glass will create a greater impact of velocity, meaning that the glass plates will hit the flat indoor floor surface with more force, increasing the amount of glass shatters created and the radius of the glass shatter spread. The glass plates quickly dropping from a higher height will make both the amount of glass shatters and the shatter spread increase. For my variables, my independent variable was the height in feet at which the glass plates are dropped. My dependent was the amount and radius of glass shatter spread. My controlled variables included the angle at which I dropped the glass plates itself, and the surface they were being dropped on. My materials included a ladder, 12 8x8 white glass plates, protective goggles, rulers, meter sticks, camera, a broom with a dustpan, lab coat, garbage can, and disposable gloves. The procedure for this experiment is to clear your area, set up a ladder, put on safety gear such as a lab coat, safety goggles, and disposable gloves. Take a white glass plate, stand straight on the floor, drop the plate to the ground at a straight angle, find the piece of glass that is farthest away from the center point that you dropped it on, and use this piece to measure the radius using meter sticks. Record data of observations, carefully collect glass shatters together using a broom, count the amount of scattered glass pieces created, record data of observations, sweep and throw away the glass shatters. Conduct 3 more trials this exact way and record data of observations. And then repeat this procedure for the heights of the third step of a ladder and the fifth step of a ladder. These experiment photos are representing how it looks like at each different height at which I dropped the glass plates on. This one on the left is showing me standing flat on the ground. This middle photo is me on the third step of the ladder, and the photo on the right is me on the fifth step of the ladder. This photo on the left is when we were measuring how high my arms are when I'm standing in certain spots to measure out in centimeters where the glass plates would be dropping from. And this photo on the right is me counting the glass shatters after sweeping them together with the broom. This photo on the left is just showing how each of my glass plates looked like. This photo in the middle was me measuring my radius with the meter sticks. And the photo on the right is just my point of view when I was on the highest point of my ladder for this experiment. This is my results shown through a data table comparing the radius of glass shatter spreads. The first height, where I was standing on the floor, resulted in 122 centimeters, and for the first trial the radius was 237, for the second it was 268, for the third it was 200, and for the fourth it was 245, and the average radius was 237.5 centimeters. For the second height of me standing on the third step of the ladder, the height was 207, and the first radius was 925, the second was 820, the third was 800, and the fourth was 495, and its radius was 760 centimeters. For the third height of me standing on the fifth step of the ladder, it was 270 centimeters, and the first trial was 730 centimeters, the second was 700, the third was 780, and the fourth was 705, and the average was 728.75 centimeters. For my data table comparing number of shatter pieces created, for the first height of 122 centimeters, there was 44 shatter pieces. For the second trial, there was 58 shattered pieces. For the third, there was 17. The fourth was 32, and the average is around 38 shattered pieces. For the second height of 207 centimeters, the first trial had 68 shattered pieces, the second had 71, the third had 94, and the fourth had 56, and the average was 72 shattered pieces. For the third height of 270 centimeters, the first trial had 90 shattered pieces, the second had 114, the third had 129, and the fourth had 130. Its average amount of shattered pieces was about 116. This is my results shown in a graph. As you can see, the radius really increased between the first and second height, but then between the second and third heights, it was very similar numbers, but the average still ended up being larger for the middle. For my graph comparing the heights versus the quantity, it helps you visually see how from between each height, the amount of glass shatters did continuously increase as the height increased. My results, according to data collected from my experiment, were that the higher the height at which the glass plates were dropped, the larger the amount of glass shatters created, but there was no clear pattern as to how the heights impacted the radius of the glass shatter spreads. There was only a distinct increase in the average amount of shatter pieces created when the height increased. The averages for the glass shatter quantity were 38 pieces for a height of 122 centimeters, 72 pieces for a height of 207 centimeters, and 116 pieces for a height of 270 centimeters. The averages for the glass shatter spread radius were 237.5 centimeters for a height of 122 centimeters, 760 centimeters for a height of 207 centimeters, and 728.75 centimeters for a height of 270 centimeters. Therefore, as the height of the plates drops increased, so did the quantity of glass shatters due to the taller heights giving the glass larger impacts of velocity. Yet the radius averages for the glass shatter spreads did not increase between the second and third height drops. For my conclusion, I can say that after conducting my experiment comparing the radius and quantity in glass shatter spreads with a variation of heights dropped, it was learned that the higher the glass plates were dropped, the larger quantity of glass shatters were created. But there was no consistent pattern within the change of radius. The hypothesis was partially supported. The larger heights made the glass plates drop with a higher velocity, creating a larger amount of glass shatter pieces. Despite this result, there was no constant change in the radius of the glass shatter spreads, considering that the radius was lowest at the drop of 122 centimeters, was at its highest at 207 centimeters, and in between at 270 centimeters. This experiment helps show what height an incident occurred from, depending on the amount of glass shatter pieces within glass shatter spreads at crime investigations. Based on this experiment, the radius of a glass shatter spread is not fully a reliable way of figuring out the height of which a glass was dropped at. Further investigation for glass shatters can happen with different glass objects and sizes. Additional studies can investigate how glass shatters are affected by angles of impact and the surface they are dropped on. This knowledge can be used to trace back the origin of the glass incident and consequently help investigators reconstruct crime scenes. Thank you so much.